Welcome to another video on AWS training. Now in this video we would be talking about different database related services offered by AWS. So the first service that we'll talk about is RDS. RDS stands for Relational Database Service. Now typically you would use this service if you have a requirement of having a relational database running in AWS data centers. So imagine a use case where you have few EC2 instances. These are your virtual machines, which are your web servers, maybe an e-commerce application which has your .NET or Java code, to present your products and its price and so on. And typically these web applications require a database, usually a relational database for storing your data, your products list, and so on. Now, if you want a running relational database like a Microsoft SQL Server database or an Oracle database, there are two different ways of achieving a relational database. One is a service that we have already talked about, which is called as the EC2 service, right? You can make calls to the EC2 service, asking it to create a virtual machine which will have your required database pre-installed onto it, maybe Oracle, SQL Server, and so on. That is one way of doing it. The other way of having a database and a relational database running in AWS data centers is AWS provides us with another service called as RDS, Relational Database Service. Again, you as a customer, this is a publicly available service, can send a request to RDS service saying, please create a Oracle database for me. What this RDS service will do is, first, it will create a virtual machine, but I'm using the white color to it because it is not typically called as an EC2 instance. Technically, AWS calls it as a DB instance. Regardless, it is a virtual machine. You don't have access to it, and we'll cover as we move on. Regardless, a virtual machine is created in which your database that you require will be pre-installed onto it, maybe an Oracle database or a SQL Server database. Sounds similar to some extent, but there is a lot of difference. The first difference is a virtual machine which is created using the EC2 instance. You have access to that virtual machine, which means from your laptop or desktop, you can actually establish a remote connection. You can establish an RDP connection to a Windows operating system or an SSH connection to a Linux operating system. So this you have operating system level access to a virtual machine created using EC2 instance. And by the way, a virtual machine created using EC2 instance is called as, a virtual machine created using EC2 service is called as an EC2 instance. On the other hand, if you create your database using RDS, though a virtual machine is created which is called as DB instance, you do not have operating system level access. That means you cannot establish a remote desktop connection to your remote desktop connection to this virtual machine. All right, so as AWS guys say, it is an isolated database environment. All right, very good. So then the next thing you will say is, hey, this is a limitation. Why would I go for it? The reason why you would go for it is because along with creating a database for you, the RDS service gives you lot of ready-made capabilities. Lot of administrative tasks are taken care by the RDS service, which if you don't use RDS, you'll have to do it yourself. Example, let's say there is a new minor version released for your database. If your database is in an EC2 instance, you will have to do the installation of that minor version yourself. However, if your database is created using RDS service, then you can configure the RDS service to say, hey, automatically apply all the minor versions released every Saturday night at 1 a.m. and the RDS service will do the needful for you. So what are we saying? First is your upgrades will be automatically applied. Second is the backups. You can ask the RDS service to automatically take backups of your relational database. And you can ask it to take backups up till past 35 days. What can you do with these backups, by the way? In RDS terms, these backups are called as snapshots. What you can do with these backups is you can create a new database from this backup, and whatever data is present in your backup would be present in the newly restored database. On other hand, if you would have not been using RDS, the whole task of taking daily backups or weekly backups, your administrator would have to do it himself or herself. Also, moving on. Other capability that RDS service provides is you can ask RDS service to create read replicas for your database. Now, read replicas means, let's say this database is a very important, has a lot of, client applications accessing your database. And because of that, there is lot of read load, lot of queries, because of which your database is getting overloaded. Now, how do you reduce the load on your database? What you can do is you can ask RDS to create another database for your master database. And this, by the way, is called as a read replica. And what RDS will do is RDS will create that read replica database, and RDS will configure asynchronous replication between your master and your read replica. Any records inserted into your master will be inserted into your replica database. But now let's come back to the load. Now, as far as the load is concerned, remember all your read queries. Now, instead of sending all the read queries to your master database, you can now offload those read queries to your read replica. So this is what we mean by scale out, a read scale out that can be taken care by RDS. Whereas had you created the database using EC2, you would have had to do all this configuration yourself. Another very important feature that RDS provides is you can configure your database in a high availability configuration. High availability configuration means RDS will create, instead of one, two databases, and RDS will configure synchronous replication between your master and your standby. This is the standby database. All records inserted into the master would also be inserted into the standby. Sound similar to a read replica? To some extent, yes, because you have multiple databases with the records, with the data replicated. However, a standby database cannot be connected by your clients. All right, it is there sitting idle. Then what's the use of it? The use of a standby database is, now typically your clients would be connecting to your master database to insert records, delete records, and so on. What happens is AWS or RDS will provide you with an endpoint, and this endpoint maps to your master database. All your client applications connect to this endpoint to insert records, update records, and delete records. Now, in case if things goes wrong, and in case if your master database goes down, what will happen? If you have a standby, RDS will automatically switch over this endpoint to the standby database, and your standby database will become your new master database. There would be a downtime of couple of minutes, but that's all. Maybe your application will not work for a couple of minutes if a failure occurs. But After the switch has happened, your connections would work as is without any changes from the application side. Difference between a standby and a read replica, as the name says, will only allow select queries, only reading of the data, only retrieval of the data. You can connect to both your master database and your read replicas at the same time. In your master, you can insert, update, delete, as well as select or read the records. In your read replica, you would only read the records. So this is a scale out solution, a read scale out solution. Whereas when you compare your master with standby, you can never connect to both master and standby one at a time, right? Your standby is a high availability solution, which means only when your master goes down, your standby comes into picture. All these capabilities are provided by the RDS service if you have created your database using RDS. If not, had you created your database in an EC2 instance using EC2 service, you will have to do all these configurations of read replicas, of standby, of backups, of upgrades, all by yourself. So I hope you see the value of the service. Moving on to another database related service, we'll now talk about a service called as DynamoDB. Now, this service allows you to create NoSQL tables in AWS data centers. So, NoSQLs, very brief, is in RDBMS, in relational database systems, you create tables with a fixed structure, with a fixed number of columns and rows inside it, and you can have relationship between the two tables. Whereas NoSQL, again, you create tables, but these tables don't have a fixed structure. One row can have 2 columns, other row can have 10 columns. So very popular NoSQL databases are like MongoDB. And if you want a MongoDB database running in AWS, you can create an EC2 instance and install MongoDB onto it. Again, that will be an infrastructure as a service. You will have to do all the management. Alternatively, if you require a NoSQL database in AWS, then AWS provides us with a service called as DynamoDB. You as an AWS customer can send request to this service and ask it to create a NoSQL table. And this is how typically I represent a NoSQL table, where the only mandatory key that would be required in your table is a primary key, and thereafter each item, each row, in NoSQL terms we call it as item, that you enter can have different set of columns inside it. Now, the way you create the table, now the same way from your applications, again, you will interact with the DynamoDB service to insert records into the NoSQL table. Likewise, again, use the endpoints of the DynamoDB service to retrieve records from the tables. All right. So basically all you do is you use the service to create tables, to insert data, to retrieve data. You don't end up interacting with any servers. Does this sound similar? So yes, this is a serverless service, right? Now, behind the scenes, what AWS does is AWS splits your data into multiple partitions. Now, all this is behind the scenes. You don't have to worry about it. But so with this, the advantage that you have is now this NoSQL table, your DynamoDB table, can range from few hundred rows to millions and billions of rows, right? All AWS will do is, if your number of records increases, if your table goes on increasing, it will just split those tables in multiple partitions. All that is behind the scenes. Again, when you are creating the table, you have the option of specifying the performance of the table that you want. Whether you expect the table to give you a performance to be able to read 5 rows per second or 10 rows per second, whether you want to write 10 items per second, and so on. And depending on the performance, so you just specify the performance. You don't have to configure anything in terms of RAM, CPU, whether an SSD based storage and so on. You just say what is your requirement. AWS will charge you accordingly. If you say I want a table whose performance is I should be able to read 50 rows per second, your storage cost will be more compared to a table with performance of 5 rows per second. Why? Because behind the scenes AWS will provision that many more resources to give you that required performance. Moving on, we'll next talk about another service called as Elasticache. Now, Elasticache is a service that allows you to store data that you want to retrieve quickly. So let's take a use case. Usually what happens is, let's say you have a web application. This is your web application which is retrieving the data from a database, maybe a relational database or a NoSQL database, doesn't matter. Usually you have a lot of data in your application that you keep on retrieving every now and then. Maybe a product list, maybe a list of countries, list of cities, so on and so forth. Rather than you retrieving that data every now and then from the database, which may be a time consuming process and would adversely affect the performance of your application, what we do is we typically store that data in something called as cache. We store it in a high performance storage. What is the fastest storage that we know? Highest performance storage is the RAM, right? RAM is much faster than any SSD based hard disk or NVMe based hard disk. RAM is much faster. So here the whole idea is frequently use data, store it in a high performance storage so that you can retrieve it faster. Now, to achieve these requirements, we have two very popular open source database solutions. One is called as Redis, REDIS. Other is called as MEM, CACHED. Nothing to do with AWS, open-based solutions. What these are these are in-memory databases. All right, something like a database, your SQL Server or Oracle or DynamoDB. All these databases store your data on the hard disk. Maybe that hard disk can be an SSD based hard disk or an HDDB based hard disk or an NVMe based hard disk. Regardless, it is still an hard disk. Whereas these open source databases, Redis and Memcached, store your data in the RAM, all right, in the memory. Obviously, if they maintain the data in RAM, the performance would be much faster. So typically for my web application, if I want to cache my data and the process of storing that frequently used data, we call it as caching. One way of doing it is I can either create an EC2 instance and install this open source Redis database onto it and then use it to retrieve my data. That is one way of doing it. Or alternatively, AWS provides us with a service called as Elasticache. EACH. Publicly available service. You as an AWS customer can use this service, and this service can create two types of databases for you. You can ask it to create either a Redis database for you. It's actually a cluster of databases. So Redis database cluster, or you can ask it to create a Memcached database cluster for you. Similar to an RDS service, you can use RDS service to create an Oracle database or a SQL Server database. An RDS service handles the administrative task. Likewise, you can use the Elasticache service. So Elasticache service in itself is not a data storage technology. Okay, it is just a service that will create for you a Redis database cluster or a Memcached database cluster in AWS environment, And once that cluster is created, then you can have your virtual machines. You can use your Redis libraries in your code to interact with the Redis database and maintain data in it. Moving on, we will now talk about another service called as RedShift. Now, RedShift is a data warehousing solution provided by AWS. Now, what does that mean? There is a service called as RedShift. Again, a publicly available service. You as an AWS customer can send requests to it. The output of this service is it will create something called as a RedShift database. RedShift DB cluster, and we call it as a DB cluster. So the icon is like this. So one database can be formed using multiple nodes of EC2 instances. Now the question is, what does this mean? Why would you go for Redshift versus other databases? Now a Redshift database is an RDBMS, a relational database system. That means in this database, you create tables with fixed structure. You can have relationship between tables. You can insert records using your normal SQL query. You can retrieve records using your normal SQL query. So then the question is, why didn't we speak about it when we just spoke about RDS? Why are we talking about it separately? Why is it called a data warehousing solution? The reason why Redshift is called as a data warehousing solution is because way internally it is designed to store your data. So let's take an example where let's say you have a table, a user table, right, which has just 3 columns inside it: an ID, a name, and an age. And basically maybe it has records 1 AA 11, 2 BB 22, 3 CC 33. Now I said that Redshift is a relational database. That means you can create tables. So let's see what is the difference between it. Let's say if you have a user table in a normal RDBMS versus if you have the same tables created in Redshift. Now, when you store this table in a normal RDBMS, all the records of a row is stored together, then the next row, then the next row. So this table will be stored something like this. One, and then you will have a common column separator, let's say a comma, then you will have AA and then 11. And then maybe you will have a row separator, let's say a pipe, 2 BB 22, then a pipe, 3 CC 33. This is how the records will be stored on the disk for this table in an RDBMS. All records of a row will be stored together. Versus Redshift is a column-based storage, which means what? The same table created in Redshift will be stored something like this. All the data of your column will be stored first, then the next column, then the next column. So the same table will be stored something like this: 1, 2, 3, then a column separator AA, BB, CC, then a column separator 11, 22, oops, 33. Excuse me for a second. All right, sorry about that. Okay, so we were talking about how the data is stored. Now, the moment I do this, immediately you will raise eyebrows. What is this? Two different designs of storing your data. There is advantages and disadvantages of both the designs. Now let's take first, it depends on the kind of queries that you execute. Let's take a first query where you say select star from user where ID is equal to 2. Now, when this query runs in an RDBMS, all it has to do is come over here, just one read operation, and retrieve all the record, right? Just one operation. Whereas this same query, if it runs in RedShift, it will have to first retrieve 2, one read operation, then retrieve BB, and then retrieve 22. So three operations, three read operations. Obviously, the row-based queries will perform very badly in Redshift. That is the reason why we never talked about it along with other RDBMSs, because typically you run row-based queries in most of the RDBMSs, and Redshift is not a good use case for that. However, there are some advantages of a columnar based design. Let's take a use case of a different query. Let's say if you want to find out average age of all the customers. Now in this case, how many read queries will happen? In case of RDBMS, 1 to retrieve 11, second to retrieve 22, and third to retrieve 33. Three operations, read operations to retrieve your data, and then maybe the average would be performed. Now the same column based query, if it has to execute in Redshift, what will happen? Just one read operation, it will retrieve all the data of a particular of this column and then perform the average. So just one operation. So you see the advantage? A column based queries would run much faster in Redshift compared to other RDBMSs. And this is where Redshift qualifies for a data warehousing solution, because typically in a data warehousing solution, you would be running your column based queries, your analytical queries. Give me the average of order of past quarter or past 1 year. And of this city and that city. You will never retrieve a row based data saying that give me the maximum order of items placed by Ceph, right? That will never happen. So typically your analytical queries, your reporting queries will run much faster in Redshift. All right, having said that, I think we have covered basically all the different database related services. Thank you for watching, and see you in next video. Bye bye.